A few examples of NFA, and we have discussed in detail how to design those NFAs. And in this lecture, we will be seeing a few more examples, and we will try to quickly design the NFAs for these examples. Alright, so let's get started. Okay, so here we have a few languages, and our task is to design the NFA for these languages. So let's see how we can do this. Coming to the first one, L1 is the set of all strings that ends with 1. So how can I design the NFA for the set of all strings that ends with 1? So let me start with a starting state, which I will call state A. A is my starting state, and A, on getting input either 0 or 1, it stays in A itself, but if the final input that I get is a 1, if it is a 1, then A goes to the last state or the final state, which is state B. Alright, so when it ends with 1, it is accepted. That is how we design this. But here there is a question that you can ask. Why did I write 0, 1 here? I could have written A on getting input just 0, it stays in A, and instead of writing 1 here, I could have written 1 only here. A on getting input 0 goes to A, and on getting input 1 goes to final state B. Why I did not write this is because if it was only 0 over here, then the only strings that would be accepted by this NFA would be 0, 1 or 0, 0, 1 or 0, 0, 0, 1. That means any number of zeros followed by 1 and 1 itself. But there are even other strings that ends with 1, like let's say 101, 1101. Even these strings also end with 1, and even these strings should be accepted. That is why I wrote A on getting input 0 and 1, it could stay in A, and if it gets input 1, it goes, the last input 1, it goes to B. In this way, all these inputs which ends with 1 will be accepted by this NFA. Okay, now let's come to the next one. L2 is the set of all strings that contains 0. Our only condition is that it should contain a 0, and the position of that 0 does not matter. It could be anywhere. So I start with the starting state A. A is my starting state, and A on getting input either 0 or 1, it can stay in A. But if you see a 0, if you see a 0, then it goes to the final state B, and even in the final state B, whether you get 0 or 1 after that, it can stay in the final state itself. Now why did I do like this? If it sees the input 0, it goes to B, and it could also stay in A itself, but in only when it comes to this B, it will be accepted. So the position of my 0 does not matter. It could be anywhere. So I don't care what is, it starts with what. It could start either with 0 or 1, and I don't care it ends with what. It could end with 0 or 1, but once there is a 0, then we make sure that it goes to the final state B, and it will be accepted. So here the position of the symbol 0 does not matter. Okay, and then the third one, L3 is the set of all strings that starts with 1, 0. It should start with 1, 0. So I start with my starting state or initial state A, and A on getting input, when it gets the input 1, I will send it to the next state, which I will call state B, and B on getting input 0, I will send it to the next state, which is C, and which will be the final state. Okay, it will be the final state, and in the final, after I reach the final state, I don't care what I get after that. Let it be 0 or 1, it stays in the final state itself. So our only condition here is that it should start with 1, 0. So we make sure that there are no other strings accepted here other than 1 in the beginning and 0 in the second part. So it starts with 1, 0, and if it starts with 1, 0, it goes to the final state or accepting state C. And after that, we don't care what follows after that, because our only condition is it should start with 1, 0. So this is how we design the NFA for this. Now let's come to the fourth one. So L4 is a set of all strings that contains 0, 1. So here again the position of the symbol 0, 1 does not matter. It could be anywhere. So how do we do this? So first we again start with our starting state, which is state A, and I don't care what it is in whatever I get in state A, 0 or 1, it can stay here. But also if A gets the input 0, if it gets the input 0, it goes to the state which I'll call state B, the next state, and B on getting input 1, it goes to the next state which is state C. And here I see that I already got the input 0, 1, and on that it comes to C, which should be the final state or the accepting state. And in C, whatever I get, again whether it is 0 or 1, it does not matter. So here we see that the position does not matter. A on getting input 0, it could either stay in A or it could go to B. But once it goes to B, only on getting input 1 it can proceed. So we see that we made sure that 0, 1 will be there somewhere in the string. Okay, so that is how we make sure. So it does not matter what it is here, and it does not matter what we get even after reaching the final state, because here the position does not matter. The only thing is it should contain 0, 1 anywhere in the string. Okay, so that is how we design this. Okay, and then the last one that we have here is L5, which is a set of all strings that ends with 1, 1. We have to make sure that it ends with 1, 1. So how do we do this? We start with starting state A, and it does not matter what it starts with. It could be either 0 or 1, and A on getting input 1, it goes to state B, the next state, because I have to get this string 1, 1. And B also on getting input, what should it be? It should be input 1. Yes, on getting input 1, it should go to the next state, which is state C, and C should be my final state or accepting state. And here I should not mention anything in C anymore. Why? Because it should end with 1, 1. When it sees this one, it comes to B. When it sees the next one, it comes to C. So when it reaches C, we made sure that the last symbols were 1, 1. So if we write anything more to this, that means that it will be something other than 1, 1. So I got 1, and then I reached the final state. So we made sure that it will accept all the strings that ends with 1, 1. So this is the way we design the NFAs for these examples. I hope it was clear to you. Okay, so since we have discussed these NFAs now, I would give you one assignment problem. If you were to construct the equivalent DFAs for the above NFAs, then tell me how many minimum number of states would you use for the construction of each of the DFAs. So here we have constructed the NFAs for the languages L1 to L5. Now try to construct the DFA for these languages, the equivalent DFAs, and tell me how many minimum number of states would you use to construct the DFAs for these above languages. So try to do this and try to leave your answer in the comment section below, and